Without further ado, we have District Silviculturist for the U.S. Forest Service, Wallows-Whitman National Forest at Grande Ranger District is Lucas Glick, and he's going to come present about this project. Let's give him a warm welcome.
Hello. Good morning. Thanks for coming out to Envirothon. This is my first Envirothon, so it's been fun to learn about the program. But as Ricky mentioned, my name's Lucas Glick. I'm a district silviculturist, which is a forester for the Grande Ranger District on the Wallows-Whitman National Forest. And Meadow Creek exists. It's a real place. I'm currently working on the project myself, so it'd be really fun to listen to your guys' teams this May to hear what you come up with. Maybe it can give me some ideas with how we want to do it. So without further ado, I'm going to introduce Meadow Creek Project to y'all. So Oregon's a big state, and the Meadow Creek Project exists in the Blue Mountain ecoregion, which encompasses Eastern Oregon, not Portland. It's about 25,000 square miles. 83% of it is in Oregon, but actually a little corner goes into Washington State. And then also the Snake River is part of the Blue Mountains, and so it encompasses part of Idaho as well. And it's got a complex geological history. It's one of the oldest mountain ranges in Oregon. Maybe you've heard of Grande fossil beds, that's in it. And so there's complex geological history out there. You know, in the late Triassic and Jurassic periods, this mountain range was under an ocean. And then, as recently in geological terms, Mount Mazama, Crater Lake, erupted about 7,000 years ago, and its ash plume covered the Blue Mountains and deposited ash over the landscape. And it was also glaciated in the Ice Age about 20,000 years ago. And the Blue Mountains has a bunch of public land, mostly administrated through national forests. There's 4 national forests that encompasses the area: the Ochoco's, the Malheur, the Umatilla, and the Wallows-Whitman. And you can kind of see where those are located. So this complex, so the LeGrand Ranger District is the administrator of the Wallows-Whitman National Forest and is proposing this project, Meadow Creek. And it shares land with private boundaries. The Starkey Experimental Forest is in purple there, and that is about 24,000 acres, and that experimental forest has one of the largest enclosures in North America. And so they fenced a perimeter around the whole Starkey Experimental Forest, which keeps in ungulates, so like elk and deer, and prevents them from distributing out of the Starkey Experimental Forest. So the premise was to set that up and watch how livestock and herbivory rates, relate with national forest management. And so it's been going on for, I think it was established around the 50s, and so it's been going on for a while, and a lot of good research has gone out of Starkey and helps guide our management decisions today. We also have a reservation just north of the project area. The Confederated Tribes of the Umatilla Indian Reservation is that area in tan, and that is a nation. It's their land, and they have a guaranteed access right with that treaty to utilize the forests in the Blues for gathering first foods, hunting, fishing, using it for culturally significant events, that sort. And so they are definitely an important player in our management decisions. So that complex geological history that I alluded to, that has really created a mosaic on the landscape. And so It's a vast forest full of different forest types. We call them dry and moist mixed conifer stands, but there's also grasslands, woodlands, and from, just the aerial photo, the pink's the project area boundary, that's our watershed boundary, you can kind of see that mosaic play out. And really it relates to that ash deposit from Mount Mazama. Ash has a structural component in it that allows moisture to stay on the site longer than our eroded basalt soils. And so wherever that ash component exists on the landscape and hasn't been eroded away, that increases your moisture holding capacity and allows you to essentially have a forest. So what's dry upland forest? Dry upland forest basically is the drier side of forest. So it's on that moisture gradient where you're just getting enough moisture where trees can actually exist. And that encompasses about 36% of the project area. Like I mentioned, there's little to no ash cap on these sites. So the water holding capacity for the site's pretty low. And you get trees on it that are more drought tolerant. And so tree species like ponderosa pine, western larch, Douglas fir, they have deeper tap roots that can go down into the soil and access farther reaches of moisture. And so it allows them to exist on the site. The blues are kind of like a typical Oregon setting where we have our moisture primarily in the fall, the winter, and the spring. And most of the time that moisture comes in the winter as snow. And then our summers are very hot and dry, and they're no stranger to fires. Actually, the Blue Mountains were named because when pioneers were crossing from the Oregon Trail, they would hit the Blue Mountain Range, and they would typically be traveling in the summer, and there would be so much smoke in the air that the mountains looked blue. So they called them the Blue Mountains. So dry forest types, they have a excess of dry fuels, and so these are easily combustible. And so when lightning comes across, they're very easily subject to igniting and burning. And so they would historically have frequent fires. We have fire hit, we can look back, and if you cut a tree, you can kind of see the rings of how many years old that tree's existed on the site. And when a fire comes, it can sometimes scorch a portion of the tree, and you can actually see that as sections where fire affected the tree. And so you can count how frequent fire would occur on the site. And most sites we see every 5 to 20 years that one site would experience fire. And so fire would act as kind of a lawnmower in the forest and take out vegetation that's not really fire or drought tolerant, and would only leave the fire drought tolerant species. And so this kind of created a forest structure that we call an open pine savanna. And so that bottom picture on the PowerPoint there, that kind of demonstrates that, where you have your overstory trees that are fire tolerant and not a lot of understory, because that fire would wipe that out. So moving up in elevation, you get a little bit more moisture. Your snowpack's starting to stick around a little bit more. You also have that ash content that I've been talking about. And that brings us to our moist and mixed conifer sites, or moist and cold, excuse me. So that the moist encompasses about 20% of the project area, and cold, the highest elevation sites, is 15. And there's just more moisture available on these sites. And so with that moisture, you have a higher diversity of tree species, plant species that can exist on the site. You still have that disturbance, but because you're higher elevation, snow might stick around and prevent fire from entering that portion of the forest more frequently. And so our fire frequency expands, and it's quite a range. It can go anywhere between 30, so be on the drier side of these moist sites, to all the way up to 300 years. And that would be our more high elevation, picture driving over the Santiam Pass from here, um, looking at where Hoodoo is. Those are our cold forests. And so they're higher elevation, colder temperatures. Fire season for those sites might not start until the end of August. And then they're going to be a much shorter duration because winter's coming. Um, so that's our moist and cold forest. And so we have this mosaic. And then within all these different forest types, we have our riparian areas. And riparian areas are just anywhere near water, lakes, streams, springs. And they represent a dynamic interface or ecotone between water and land-based ecosystems, where both components of the system interact. And it's very important, but they're not in a vacuum. They experience the same disturbances as those upland forests. So fire would frequent through these riparian areas, just like they would in dry, moist, and cold forests. And they can have mixed effects. If it's a low severity fire, you're not going to see a lot of plant vegetation growth go away from those riparian areas. If it's a high severity fire, severity is just intensity and how much mortality occurred from the resulting fire. That can really, change what the landscape looks like in the middle. And then, what's unique about these riparian areas is they have different plant flora than the neighboring upland forests. And so you get a deciduous plant community like black cottonwood or aspen. And so they provide unique habitats. So this environmental harshness and disturbance severity and intensity help maintains this biodiversity that we see in the Blue Mountains. And there's kind of a Goldilocks zone for moist forests because they have the most biodiversity because their environmental harshness is kind of right in the middle, and the disturbance intensity and severity is also right in the middle. To the left, you have more environmental harshness, less moisture. That's your dry forests. And then you have cold temperatures. That's your cold forests. And all these forests are subject to disturbance agents. And in the blues, we have a lot of endemic insects and diseases. I'm sure you've heard of bark beetles, which we definitely have: mountain pine beetle, western pine beetle, spruce budworm. That's a defoliator, meaning the insects are living off of the leaves or needles of the tree. We've got Douglas fir tussock moth, all these different insects and diseases that play a unique role with these forests. There's also root diseases like armillaria or western dwarf mistletoe. These are pathogens that feed off of the tree. Other disturbances are logging. The blues are no stranger to human influence. We had railroad logging back in the early 1900s to the 1950s. They used splash dams where they would fall trees into creeks, dam up the creeks, and then when you kind of have a reservoir behind it, they'd blow up the dam and send it down the river to the mill. As soon as humans started occupying this area, they brought in their livestock to build their livelihoods. So grazing's been a big disturbance agent. Fire, both planned and unplanned ignitions. Again, lightning coming in every summer would cause fire to frequent across the landscape. And then as soon as humans came in, they would also introduce fire into the landscape. And then wind events, of course, high weather, that can really change a landscape. And so how this would play out with the forest is it would kind of create a shifting mosaic of different stand types. And many landscapes exist as a shifting mosaic of patch types. Plants will build into a stable condition, which is what we call a climax, or it's an endpoint in succession. And these climax points are actually quite rare when considering a whole landscape on a whole. And instead, you get a different mosaic of different plant communities at a broad scale. And this variance would uh, exhibit a stable frequency distribution of vegetation states. And so, as one climax patch disappears, another one would grow up and take its place. And so, talking about forest succession, forests develop through time, and they typically need a stand level disturbance, whether that be Mount St. Helens blowing and wiping out all the landscape or a wildfire coming in. But there's some stand initiation event that wipes off all the competition. And then as neighboring trees will seed that area in, trees will start to establish themselves. And soon enough, they've established the whole site. They've colonized the whole area to the point where there's no more available resources. And so then they start to compete with each other and actually exclude other species from coming onto the site. And as that occurs, you're going to get this inter-tree competition that causes mortality. There's going to be some winners and some losers. And when there's losers, they'll disappear off the site and create open growing space for, another species to recolonize that area. And so that's jumping from the stem exclusion to the understory reinitiation stage. And then as that dynamic plays out, after about 150 years, we kind of get into this old forest stage, and that's our climax. And it can stay as an old forest state until some stand level disturbance comes in and clears it out, and the process starts over. And so we get this range, and we call it this range of variation. And the range of variation recognizes that ecosystems are complex and experience a range of conditions which, across the process, are resilient and self-sustaining. And when allowed to move beyond these limits, the range of variation, ecosystems disassemble and they move into a state of disequilibrium. Oops. So you can kind of look at this diagram here, and this shows the ecological trajectory of an ecosystem component. That's that solid line going through time. And you have your different landscapes across the ecosystem. And they vary due to disturbance events. And this is meant to talk about this range. And as long as the ecosystem stays in this range, no matter what those disturbance events do, it can kind of bounce back and continue to move forward. However, when it moves out of this range, the ecosystem might not have the tools to recover to bounce back into its state that it was once in. And so it would be out of that range. And so the goal as a forest manager on the landscape is to try to manage the landscape to continue in this range, because what happens there is we're hedging our bets that even if there is going to be disturbance, which we know we're going to have, these insects and diseases are endemic to the area. We know every summer there's a potential for a fire to start. It's going to have enough different and resiliency to these disturbances to bounce back and keep functioning as as a as an ecosystem that meets our goals and objectives. And so what can happen and what has happened is you can get overrepresentation or underrepresentation of these different forest conditions. And so if you have that overrepresentation of conditions, that might make it out of our range and prevent the system from bouncing back. So trying to stay within that range is a key component of what we look at when we're trying to manage ecosystems. And now we have to consider climate change, because although these disturbances have been occurring on the landscape for a long time, climate change is actually changing how these disturbances interact with the landscape. We know that as it gets hotter and drier, that changes our snowpack. And, here's two diagrams that kind of shows how that's influencing, forests all across the West. With warmer, drier temperatures, our precip is changing from snow to rain, or is melting faster. And so that's preventing moisture to stay on the site for a longer duration. And that dries out our fuels and our forests, which then when there's a lightning event, that can increase the fire frequency. And so most of the blues in this diagram shows that it's actually 6 times more likely to burn than than what we've currently experienced. So that's quite a bit more. It's a lot of fire. And also, with this drier condition, it can influence the disturbance agents of insects and diseases, because insects are kind of like hungry teenagers. They just want to go out and eat all the cheeseburgers they can. If you hand them a whole plate, they'll eat it. I remember when I was growing up and my mom was feeding me, our food bill went up by 4 times, she said. And then when I moved out, she kept buying the same amount of food, and she's like, "Oh, we can't eat all this. So I got to change my habits." Insects and diseases are the same way. And so there's a forest out there of available host species, and as it's gotten drier, they have those host species have less resources to defend themselves. And so the insects are going to and diseases are going to capitalize on that. And that's how you get insect epidemics. And so, furthermore, the forests and the blues haven't been able to experience those normal disturbance frequencies that we thought existed prior to Euro-Americans coming on the site. Inherently, we've been pretty good at putting out fire, and this has caused fire suppression across a lot of forests in the western U.S. And this has kind of changed both the horizontal and vertical structures of the forest. That fire that would act as a lawnmower through our dry forests, that's been taken away, and so the grass has gotten tall. Fire intolerant species have been allowed to come in and colonize the site. And they're now competing with our more drought tolerant species. And they sometimes can grow underneath our fire and drought tolerant species, which then can act as a ladder fuel. So when a fire does come in, let's say it's coming across the surface, it hits a little smaller tree that's not fire resistant, so it combusts and burns up, and it's directly below the canopy or the drip line of a fire tolerant tree. Well, that smaller fire intolerant tree is going to act as a ladder fuel and transition that fire from the ground into the canopy of those fire tolerant species. And that can cause a crown fire, and then crown fires are a lot harder to manage than a ground fire. We've also done a lot of grazing in the blues, and so this is, um, kind of changed how different understory species, forbs, and shrubs, because obviously sheep and cows are particular about what they'll eat and what they won't, and so um, it's prevented, some of those maybe culturally significant plants like huckleberry from colonizing the site because they've been getting grazed. Grazing can also cause compaction, which prevents any species of plants from growing back into the site. And then, of course, logging. Logging is changed the forest structure by physically removing trees. And historically, the big pines, the fire tolerant, drought tolerant species, those were sought after. Those made great 2x4s for houses. And so, um, we would high grade our sites of those pine species and then allow the less drought and fire tolerant species, we just leave those to recolonize the site. And so that's kind of changed the composition of the species. So we recognize all these different changes that the landscape has had, and the Forest Service wants to basically keep the trajectory going of this landscape in Meadow Creek so it can meet the needs of people and animals and continue to provide the ecosystem services that it does. And so, as Ricky mentioned, you guys aren't focused on trying to create management that aligns with our forest plan standards that are established by Congress or meeting the Clean Water Act, the Endangered Species Act. We're not going to go into that. We're going to just focus on some project-specific objectives. And those are to develop treatments to create and maintain vegetation conditions that are more resistant and resilient to anticipated increases in fire occurrence and severity, insect and disease risks, and changes in regional climate patterns. We want to create and maintain fuel profiles that minimize risk to the surrounding resources. The Confederated Tribes of the Umatilla, their reservations just north of this project area. There's some private inholdings. Starkey Experimental Forest is a huge piece of infrastructure that has had a lot of money go into it. And so protecting those in the event of a wildfire and providing for firefighter safety is going to be a key element. We want to restore ecosystems that support culturally important food sources, improve aquatic and terrestrial processes that sustain these foods, and can provide clean and cold water for anadromous fish and aquatic species. Those fish species are, of course, salmon, steelhead. Meadow Creek is a tributary to the Grande, which is a tributary to the Snake, which is a tributary to the Columbia. So salmon historically were all across the blues, performing their life cycle. And then lastly, maintain and enhance connectivity of ecosystems while doing this management will be key. And we do that by providing corridors and maintaining and promoting existing security areas to provide more resilient and sustainable wildlife populations, including big game distribution. So how do we do this restoration that we want to achieve these objectives? Well, there's two recognized approaches. The first one is active. Let's go out and do things. This approach involves management, implementing management activities such as prescribed burning, logging, small tree thinning, to restore these appropriate conditions on the landscape that will meet these goals and objectives. The other one is passive, and that is an approach that involves removing the stress that caused these ecosystems to degrade in the first place, like fire suppression, and allow these natural processes, natural disturbances play out and build that landscape integrity. So let's talk about passive first. This is kind of like no action. So, given the state of these stands, having fire suppression, timber harvest, grazing, they're not in a condition that we can just say, hey, no action's going to solve all our problems, potentially. Because we've suppressed fire for about 80 to 100 years in some of these sites. The fuel loading, imagine if you didn't mow your lawn for 100 years. The lawn would look a little different than what you really want it to look like. And so there's a lot of fuel loading, a lot of ladder fuels. And so if we just say, we'll just untouch it, stop preventing fire, we might have some unintended consequences, given their current state. And so these stands in the forest in Meadow Creek are at an increased risk to high fire severity. And that can totally wipe out a stand. And then we lose our ecosystem services, we lose our structure, we don't really meet our objectives. Same case for, insects and disease risks. There's plentiful hosts out there for insects to just devour, and so not giving the resources to build up defenses for those species, really puts the forest at risk to insect and disease epidemics. And then we again result with a loss of structure and ecosystem services. So let's think about active restoration. And we know that climate change kind of is going to encompass all these different stressors. And so we can think about doing restoration on our forests and focusing on 3 components: composition, structure, and stand densities. And so some active restoration tips and tricks that we can use to help build that resiliency back is, we know fire is going to be more frequent and drought is going to be more frequent. So let's think about our species. Let's promote species that have fire tolerance and are more drought tolerant. While thinking about that, we don't want to just a homogeneous landscape of only fire and drought tolerant species, because those other species provide real key, hiding cover for ungulates, or, maybe a food source for a bird. So we do still want to maintain a mix. We can think about the structure on our stands. Right now, there's a lot of ladder fields, a lot of dense forests out in the Meadow Creek area. So we can reduce those ladder fuels. We can promote, diverse age classes. We can favor those early cereal species. And then also looking at it at stand density, the stands out there are at a higher density, more trees per acre, more fuel for a fire to come in and potentially burn through. So what we can do there is remove some of that vegetation, space it out a little bit more, slow down fire from jumping from one tree or plant to the next. We can go back to these historical densities that we thought occurred if, frequent fire would have occurred across the landscape. And, manage these stands to limit competition between one another, to limit that inter-tree competition. And so we do that by emulating disturbance. And you can do this in 2 different manners. You can kind of start the stand over because the stand is too, maybe it doesn't have any drought tolerant species. It doesn't have any of those objectives that you want. So best just, start the stand over. And so that would be a stand initiating disturbance emulation. And that's like kind of mimicking a crown fire. And so if you wanted to prescribe a treatment that would be a stand initiating event, that would be more like a regeneration harvest. So those are known as like clear cuts or seed tree harvests. The other option you have is, work with what you got. And so that you can take either a bottom up or a top down approach, depending on your stand conditions. And these are more stand tending treatments. You're trying to, once again, work with what you got. And so these mimic, uh, disease like dwarf mistletoe from the bottom or surface fire, where it's going to remove some of the trees on the bottom component of the stand, but primarily leave the overstory. And this can take into shape for management options like a thinning or release, where you thin out the small and the old and the disease and you leave the best. Or you can kind of look at it as like a top down approach. And this emulates more like root disease or snow avalanches, wind events, something that takes out the overstory but works with the understory. And you can emulate that in with a silvicultural treatment of overstory removal. And so I just mentioned what this silvicultural treatment. And so as a forester, you are a silviculturist. And silviculture is just the art and the science of controlling the establishment, growth, composition, health, and quality of forests and woodlands to meet a diverse needs and values of landowners and society, such as wildlife habitat, timber, water resources, restoration, and recreation on a sustainable basis. So, it's your students' job to kind of think about silviculture systems that they can use in Meadow Creek that are appropriate, that emulates that disturbance, to try to reach those goals and objectives. And so these are some examples: thinning from below. Those intermediate treatments have pros and cons with them. With intermediate treatments, you're not removing the stand totally, you're working with what you got. And so the plus side is you don't have to start from scratch. You'll still maintain some sort of ecosystem service like overstory structure for habitat for a diverse array of wildlife species. You'll still have that forest that could provide shade to a riparian area. So that's a nice pro with it. The cons with intermediate treatments is, sometimes that treatment is more costly than the work it takes to do that work. And so, trying to find funding from Congress or private landowners or any environmental group, that can kind of be hard. You have to be able to rally some resources for that. You also risk, we're not trying to fireproof a landscape. That's kind of impossible. And so there's still that risk that even though you do that treatment work, it might not be effective. So you'll have to be able to evaluate that. Looking on the other side of things with stand initiating treatments, that again is removing everything off the landscape. So you're starting over. So if your goal is to get more old growth, you got to wait a long time after that event for those for that stand to develop into that old growth condition. So if you're short on old growth, that might not be appropriate. However, you're going to maximize the amount of, volume that comes out of that stand. And so that might pay for the treatment itself. It might be economically feasible. So you don't need to rely on other revenue sources to pay for that treatment. So it's kind of a balance that you have to weigh. And we would like to use adaptive management after we use these systems to make sure that, one, we're, trying to assess the problem and, make a decision that eventually meets our goals and objectives. And we do that through the adaptive management framework. And so after assessing the problems, we develop a list of objectives that we need to do, and those are the ones I shared. And it's your student's job to design um a plan to get us to meet those goals and objectives. And then as the Forest Service, we do that same thing, and then we go out and implement those projects. And after we implement it, we monitor to make sure that one, the treatment worked in the favor that we thought it, what we said we thought would happen happened. And if it didn't, how can we evaluate it and adjust to make sure that our objectives are being met? Do we need to, maybe thinning, for example, is not enough. Maybe we need to do a thinning and a prescribed fire to really get that landscape um, to emulate that open pine savanna that I mentioned. So being able to adjust and problem solve and um, evaluate those are important concepts. And then just as important is to make sure that we tell this story through getting people out there, like the Umatilla tribe and our public stakeholders, environmental groups, logging um, uh, associations, and try to build trust and say, okay, this is the plan that we created. These were the goals and objectives that we wanted to do. Here's how it turned out. Here's what we learned. Some things we can do better, other things we think we have a pretty good handle of, and we're going to proceed forward with doing more of that. And so using that adaptive management framework really helps us build trust. And it's my job to go out in collaboration groups to talk about forest management. And it's really a crucial influence on our ability to get work done because it builds that trust. And without it, the Forest Service can say and do whatever they want, but we're going to get held up in court by people that disagree with our management practices. So really, it's a good way to build trust and move forward. So that's your goal, and that's the Meadow Creek overview. I'm around for lunch, but I think we have 15 minutes for questions or so. So if you have any questions, feel free to.
Thank you, Luke. Great presentation. Let's give him a round of applause.
I just had a quick one about the adaptive management, that last thing you were talking about. Is part of it when you're creating your objectives to involve stakeholders? So when it's not just after or as you're monitoring and adjusting, it's like in the beginning too, right?
Yeah, exactly. We didn't really go into it, but to assess the problems and kind of create our objectives, we get that through the U.S. Department of Agriculture, which the Forest Service is under, and they, have a lot of different stakeholders that they have to answer to. And one is like the tribes, for example, and seeing what the tribes want. And so they kind of develop these overarching goals for the U.S. Forest Service to kind of tackle, but it's, sometimes more site specific. And so knowing what our stakeholders want beforehand kind of helps guide those objectives.
Thanks.
I have a question about adaptive management. When you're coming up with your forest management plan, do you include anything for this? Or is this just as you're going through the plan? Like, we don't know what's going to happen. So do you include that in the plan? Like, oh, in the event X, we do Y. Or do you just, as you're going through the process, do you monitor that way? Did that make sense?
Yeah.
Okay, thanks.
We do both. Yeah. So our forest management plan that we've established, that included adaptive management in the building of it. we create alternatives so we can evaluate the pros and cons of each of those alternatives, and then we present that out to our stakeholders and say, hey, with alternative A we can get a lot more timber output, but we might result with less habitat. How does that sit with people? So we create those alternatives to show different management approaches, and then it's kind of the agency's job to try to navigate and weave through all that public opinion to decide on one that kind of encompasses everyone's objectives as best it can. And then when you're doing the project, being upfront with your different alternatives, you could look at one stand, for example, one site, and say, well, we could, apply just prescribed fire. What would happen here? We have too many ladder fuels. The whole stand would burn up. What if we did thinning? Well, that would space everything out, but we don't have that fire component that, some species need to regenerate. So maybe the best approach would be a thinning with fire, that kind of thing.
On your human influence, there wasn't a recreational influence there. I was kind of curious as to why there wasn't.
Yeah, recreation has definitely an influence on it. I just had some broad human influences that I put down. So yeah, that was an oversight on mine. But recreation can definitely have an impact on it, depending on what the recreation activity is. But like biking, for example, if you're biking through the forest, that can disturb wildlife species, for example, that are trying to find hiding cover. So definitely recreation can have an impact on it.
Do you have some examples of what recreation takes place in this particular area?
Yeah, kind of anything that you like to do outside. Hunting, fishing, hiking, mountain biking, horseback riding, wildlife observing, pretty much anything we like to do in Oregon.
Excellent.
On that same, you happen to have any figures or know what the visitation per year is in the primary period of time that happens for recreationalists?
I don't have any figures off the top of my head, but I bet, like, doing a Google search for the Wallows-Whitman, there's probably some sort of indicators of how much visitation we get per year, but I don't have that knowledge off the top of my head.
You have one more.
On that same note, are there any restrictions for the Meadow Creek area currently in place as a restoration site, or is it accessible to all visitors?
So it's public land, so it is accessible to all visitors. The Starkey Experimental Forest, which is like 25,000 acres of the project area, that is enclosed, and they actually close it off during the winter. So it's like November 30th through May 1st. They close the area to anyone, basically, because they're trapping ungulates like elk and deer, so that they can do studies and monitor health of the herd populations, and so there is a closure on that, but the rest of the area is open to the public.
So lastly, on that closure, is that an excluded area from, say, grazing, as well as their fences that are used for that exclusion?
They do graze in it still during the summer, but this area is all under snow during the winter, so grazing opportunity is pretty limited during the winter. So typically cattle and sheep are put on the forest around June 1st and taken off October 31st.
Thank you. Yeah.
Sorry. Are there any endangered or threatened species in the area?
Yeah, good question. There are. There's some rare plant species. They would be considered threatened. Some forbs. Kind of forgetting what exact ones, but there are definitely some different forbs and grasses that are sensitive. That how we would handle those in a management standpoint is typically look at the life cycle of those plants and and if they, are at risk to compaction that could occur through management, we'll typically buffer those areas. And then, as in terms of wildlife species, there's goshawks, which are threatened and kind of the key indicator species, meaning if you have goshawks in the landscape, you know that it's functioning. Um, and so it's a keystone species. And with those, we buffer their nests with a 40-acre buffer, and that would be a buffer of any management activities. So we're kind of letting them be in their nest area. And then we also have a operation restriction period where after they have their babies, there's this post-fledging area where they're trying to, feed and make sure that they can kind of make their offspring grow into healthy adults. And so there's an operation restriction in there that would, prevent any disturbance to um, their hunting. And that would just be a period of time.
Would there be any cameras around
Yeah,
those
there's a
sites
lot of
that
cameras.
we could look up with our students?
I'm not. Yeah, I think if you reached out to the Starkey Experimental Forester, they could probably share that.
Okay.
Yeah, but there's definitely game cameras, and they have lots of photos of the elk herd that resides there every year.
And just real quick, for your students' presentation, don't get bogged down on one federally regulated species. We would like them to mention that and to think about it in their plan, but you don't have to like base the whole presentation on an endangered species in that area or something like that. We just don't want you guys to get too bogged down on it. We want it to be part of the management plan, but also like don't have to consider every single one. If you mention a couple, that's kind of what we're looking for.
Yeah, can you go back to the original map of the Meadow Creek area here? And
This one or this one?
I think it's that one. So Meadow Creek is, I'm just trying to figure out how many acres this area is and what elevation. Is LeGrand in this map? Or
Yeah,
let's go over just the general area real quick.
LeGrand's right here, and the Meadow Creek area is about 35 air miles to the west of LeGrand. I think it's on that paper that you guys have. Is it on my slide? I didn't put it on this one. There you go. 50,965 acres is this area.
Hello. Okay. We have one more thing when you're considering threatened and endangered animals. Julie has some resources.
Many of you have probably used it before, but the Oregon Conservation Strategy Plan has for each region of the state. So it has like the Blue Mountains and it has the T&E consideration for that state. And if you picked up the booklets that we were giving out, the priority species booklet, that's also by region. So there's the Blue Mountain region is in there, and it would have what would be those of consideration. And so as Luke was mentioning, they look at those of consideration and then can adapt for it. But as mentioned, it'd be good for your students to mention, but it's not a big focus because you're going to just make the assumption they're following all those different regulations. We don't want students to get too hung up on those specific regulations, but that would be a good place to help students get just a general overall for what's those of concern.
On that bipolar road, in the areas in that restoration site that freeze internal. Yeah. These is a private holding.
Those are private in holdings. Yep.
Couple more minutes for one more question, two more questions. No? All right. You guys are all ready for lunch then. Let's give Lucas Glick another big round of applause.
Thank you. Yeah, I look forward to seeing what your teams can come up with.